Hello guys, we're going to start with 10.5 log equations, and what we have to be able to do with this is just simply solve when we have two log equations, for now where the logs are on both sides, and then we'll talk about one problem where the log is not on both sides. And the thing is, of course, they start out very easy. If you have the same log here and the same log here with the same bases, as long as they are log base 2 and log base 2 both, then you can simply cross them out and simply set negative 5b minus 3 equal to 3b plus 5 minus over, you get negative 8b equals 8 and b equals negative 1. Okay, and then of course, because it's an equation, you could always go and check and see if they work out to be the same. Go ahead and look at this problem. Obviously, they're both in log base 2. Log base 2, can you pause the video for a second and take a second to solve? So at this point, I can simply just basically drop the logs again, and it's 10, 5x equals 15, and x is 3. So, all right, the next question is a little different. It now has two logs on one side and one log on the other side, but the good part is that everything in the problem is log base 4. So what we have to do is remember our log of logs, that if this is a subtraction sign right here, what do I need to do with these? So I can rewrite this as one log, log base 4, and remember, subtraction means division. A subtraction sign looks like a dividing sign. So I can write x squared over 2 equals log base 4 to the 19th. And now, since I only have one log on the left and one log on the right, and they're both in the same log form, I can cancel this out, and I can get x squared over 2 equals 19. And then solve, and if you remember, the 2's on the bottom, so I'm going to want to get rid of 2, and I get x squared equals 38. I square root it, and I get x equals square root of 38. But here's where we have to focus on something. Please remember, when we take the square root of a positive number, we have two answers, plus or minus the square root of 38. Now, it has to be very careful, because remember, we can never take a logarithm of a negative number. So, but if I go up and take the negative square root of 38, and because this is the only place that I would have to plug it back in, if I plug a negative in a squared, it's going to become positive. So this case, it's both answers, plus or minus the square root of 38. But remember, in other cases, if it did not plug back into a squared, that you had a log of a negative number, it cannot happen. Okay, I did have to fix this video because I had a mistake at this problem. So if I already talked about this problem, ignore it. We'll start back over. What we have to look at this problem is there's two logarithms on the left side of the equal sign, but there's no logarithm on the right side. So that's where it's a way different problem than it is this one, where there's a log on both sides. We're still going to start the problem the same way, that if I have two logs, 1 and 2, on the same side of the equation, that I do want to get it written as one log. So log 3x, and now remember, it's a plus sign, and plus means multiplication. So I'm going to do that, equals 3. Now, since there's not a log on both sides, I can't just cross out log base 3 and pretend that it doesn't exist. But what I can do is see that this is simply just a logarithm equation. And so base to the power equals the number. So I can say 3 to the third equals x, x minus 6. So in that case, 27 in the first video, when I did this problem, I made that a 9, so be careful, x squared minus 6x. Now I'm going to get x squared minus 6x minus 27 set equal to 0. Okay, and at this point, I'm going to factor, so I'm going to get x minus 9, x plus 3 equals 0. So I'm going to get x equals 9 and negative 3. So we get two answers, and if you see at the top of the page, it said to check for extraneous solutions. Remember, we can never have a log next to a negative number. You cannot take the log of a negative number. So in this case, the 3 will not work, and my only answer is x being 9. Okay? Why don't you try this one, set it up, pause the video, see if you at least set it up for itself. Remember, logs on both sides. Remember, please remember this, if there's no base next to that log, what base is it? And we're going to need that because you're going to need that number when you go to solve. So I want to set up on the one side. So I get log. I have a 5x. It's a plus sign, which means multiplication. So I have this equals 2. Remember, this is a base, and if you need to redo it, it's a base 10. So there is a number there when there's not actually showing. So because there's not logs on both sides, we need to just take 10 to the power of 2 is 5x, x plus 10, base to the power equals the number. So go ahead and solve this out. Minus 100 when I bring it over. From here, I see it has a GCF, so I'm going to make this and at this point, factors of 20 that get me 10. Can't do, right? One and 20, 2 and 10, 5 and 4. So I can't get it. So I actually have to complete the square on this, or use the quadratic formula. So that's kind of no fun, but I get x squared plus 10x plus blank equals 20 plus blank. Half of 10 is 5. 5 squared is 25, and 25. So I get, so remember I'm just completing the square, I get x squared, x plus 5 squared equals 45. I am then going to, at this point, take x plus 5 equals plus or minus the square root of 45. X equals negative 5 plus or minus the square root of 45. And when I do that in a calculator, negative 5 plus the square root of 45, I get 1.7. When I take negative 5 minus the square root of 45, I get negative 11.7. And so if you realize, again, if you go check up at the top, you have an x, a 5x right next to the logarithm, which means I cannot put in a negative number, so my answer would be 1.7. So go ahead, try this one, definitely all by yourself. Check for extraneous solutions, make sure that you don't get it. So go ahead, pause the video, stop it, try it all by yourself. Okay, remember it's definitely in log base 10, don't forget that because there's nothing. So if you wanted to write a 10 in, not to confuse you, hopefully you did that. I'm doing this quick because you should have tried it by yourself. 10 to the power of 1 gives me x, x plus 3, since that's a logarithm. 10 equals x squared plus 3x. X squared plus 3x minus 10, I move it over. X plus 5, x minus 2 are factors of 10 that get me 3, ends up being negative 5 and positive 2. I can't use the negative because it's next to, right here, it would make that term negative next to the logarithm. Okay. Now look back at this one. I throw this back in so it does not confuse you. You've got to see the difference that in this one there is a log on this side and there is a log on that side. So all I need to do is combine the two logs on one side. Sorry about that. Okay, so I get log 6, 8 over 2, since it's a minus sign, that's division. So again, since you have log base 6 and log base 6, they cancel and you get x plus 3 equals 4, because 8 divided by 2 is 4, and x equals 1. So it's very simple. Just pay attention when there is logs on both sides and there's not. So if you would go ahead and do this one, please be careful. There's not a log on both sides. So base to the power equals the number inside. It's obviously going to have an x squared. So please factor. In this one, there's only an x squared, so you have two options. You can move this 9 over and get 25 equals x squared, but please remember when I take the square root, it's plus minus negative 25, which is plus minus 5. When I go back up here, because again, I'm putting in a negative 5 only in an x squared, that's going to turn it positive, so this case has two answers, 5 and negative 5. You could have also, just as a heads up, at this point, if you needed to here, you could have wrote 16 equals x squared minus 9. You could have moved the 16 over and got x squared minus 25, and at that point it factors to x plus 5 and x minus 5. That's why there's two answers. So if that would have helped you too. Okay, hopefully from here you guys can kind of work together and work on the worksheet. Thanks, bye.